Hey guys, welcome back. Coach Spots here. Today we're going to talk about parallel and perpendicular lines. Okay, so let's have a working definition for each to start. Okay, so parallel lines have the same slope. So two lines are perfectly parallel if they have the same slope. Meaning, if we had a graph, we have one line, a parallel line to this would have that same rate of change where they kind of look like railroad tracks. Okay. They have the same slope to them. That's kind of the main idea between parallel lines. All right? So let me give you, so boom, write that down. Parallel lines have the same slope. You're going to need that. And then here's an example of two lines that have the same slope. So specifically, this line, hey, that's written in slope-intercept form. Okay? So we have y equals 3x plus 7. Switch to the belt. Our slope is 3 for this line. We have another line, okay, this is in point slope form. So actually, now that I'm thinking about it, I don't think I've taught you point slope form yet. You get to watch that video and learn that on the Monday we come back from break. So I guess I could redo this, but this is the slope on a point slope form linear equation. You'll find that out in my next YouTube video. But notice both lines have the same slope of 3. So I could rewrite this. Y equals 3x minus 2. Notice it does not have to have the same y-intercept, then it would be the same line. These just have different heights, different y-intercepts, but the same slope. Okay, so these are examples of parallel lines. Okay, so let's do a problem right quick. Go ahead and press pause and write this down. You should have unpaused it by now because you should have already written all of this down. We just read it off. It says, write the equation of a line through the point 4, 7 that is parallel to the line y equals negative 1/2 x plus 2. Okay, so let's talk this through. It says, write the equation of a line. Our line goes through the point 4, 7. So we are going to highlight 4, 7 as a point on our line. What we want now is the slope of our line. Because we have a point, now we want the slope. Let me make this very clear. This is not our line, okay? This is a different line. Completely different line. Our line, I'm going to do blue for our line, is parallel. Our line is parallel to this line, which is a different line. So the only thing we want out of this line is the slope. Our line is not this line, okay? This line has its own slope right here. Our line is parallel to that. And we just learned parallel lines have the same slope. So now we know that our line has the slope of negative 1/2, okay? And the reason we know that is because this line has a slope of negative 1/2, and we're parallel to that. Once we know that information, we don't need this other line anymore. In fact, it's only going to just mess us up. In reality, this becomes a problem very similar to, or it really just becomes a problem where here's our point, 4, 7, and here's our slope, negative 1/2. And now it just becomes a problem of, hey, we know our point, we know our slope, go ahead and write the equation. And so far, all you know is the slope-intercept form, so we're going to work with that. Y equals mx plus b. Y equals our slope, negative 1/2, x plus b. We are looking for the b value, okay? We know an x, we know a y. We're going to plug that in for x and y. Okay? Notice I plugged in 7 for y, 4 for x. Negative times a positive is a negative. 1/2 times 4 is 2. Add 2 to the other side. And we get that b equals 9. And now that we know what b is, and we know what our slope is, now we can write our official final answer in slope-intercept form. Y equals negative 1/2 x plus 9. And that's our final answer, okay? So that is how we deal with parallel lines. Now let's talk about perpendicular lines. Once again, pause this so you can write the definition down. All right, you probably unpaused it by now. Perpendicular lines have negative reciprocal slopes. Remember, reciprocals are like 2/3 and 3/2. But if they're negative of each other, that just means one is negative, the other is positive. So if this one was negative, this one is positive. If this one was negative, that one would be positive. One of our two slopes is positive, one is negative, and they're reciprocals of each other. Here are some examples of slopes that would be perpendicular lines. So if we had a slope of 1/3 and another line with a slope of -3, those would be perpendicular lines because these are negative reciprocals of each other. The reciprocal of 1/3 is 3/1, and then we need to make it negative. The reciprocal of 7 is 1/7, and then make it negative. The reciprocal of 2/5 is 5/2, make it negative. The reciprocal of 4 is 1/4. It already is negative, so we make it positive. Okay. The reciprocal of -1/2, the negative reciprocal of -1/2 just becomes 2. So what we're saying is these combinations of slopes in lines would be negative reciprocals of each other. So these would be perpendicular lines. So for example, if I had y equals 5x plus 7, and then another line, y equals 1/5 x minus 3, these would not be perpendicular because they're both positive. Okay, what would need to happen, even though they're reciprocals, one of them would need to be negative. So either that needs to be negative, now they would be negative reciprocal slopes of each other. Now we could say these are perpendicular lines, or we would need this one to be negative. Okay? So for example, and I don't know why I keep using 7. Okay, so first off, 3 and -3. They're not the same, so they're not parallel. 3 and -3, they're negatives of each other. One is negative, one's positive, but they're not reciprocals, so they're not perpendicular either. In order for them to have been perpendicular, one would have needed to be the reciprocal of the other. Okay? So now let's copy this problem down. Press pause. All right, you should have unpaused it by now because you should have copied this down. Okay? Write the equation of a line in slope-intercept form that goes through the point 3, -2. So this is a point we want. Okay? And we want to be perpendicular to this other line. Once again, I haven't actually taught you point slope form yet, so let me just highlight. This is the slope on point slope form. Okay, you will get to a problem like this the Monday we get back from break. You will see point slope form a lot more, but I just wanted to preview it now for you. And since I'm highlighting where the slope is, that's totally fair. Okay, basically here is this other line. It's not our line, it's just some other line. And that other line has a slope of 1/3. Well, if our line is perpendicular to this other line, then our line has a slope. This is positive 1/3, so ours has a negative slope, and the reciprocal of that is 3. So our slope is -3, and it goes through the point 3, -2. So I'll write that on another page. 3, -2 is the point it goes through, and the slope we said was -3. Again, if this is too fast, pause it, process what's going on, rewind it, rewatch it again, that's totally fine. I'll even go through and write the equation of a line in slope-intercept form. So we want to write our answer in y equals mx plus b form. We kind of already knew that. That's all I've taught you so far. And it goes through a point and is perpendicular to this line. This is some other line. We don't actually care about it, except we want the slope of that line to help us find our slope of our line. Now that we have that, here's x, here's y, right? Y equals mx plus b. We can literally set up a quick equation. -2 equals -3, that's our m, times our x, which is 3, plus b. -2 equals -9 plus b, add 9 over. 7 equals B. Now that we know that, all right, so 7 is B. The slope is -3. Boom. Very easy, very straightforward. I hope this video has helped. Tried to make it short and sweet. So I hope you guys have a great break.